Thank you all for joining this last session of the day. So it's really good to see so many of you here. My name is Loek. I come all the way from the Netherlands, across the pond. So I live close to Amsterdam, and I'm the proud owner of my own consultancy firm since a couple of months. I'm here to talk to you about Aspire Beyond the Basics. I do assume that everyone here has at least some working knowledge with Aspire, but can I just see a raise of hands if you have never worked with Aspire before? Not a single line. Yeah, that's what I was afraid of. Don't worry, in my abstract it says I skip the basics, but I will give you the absolute minimum of the basics, so you at least have a good working knowledge of the product. So what can you expect from this session? It's a deep dive session. It will go beyond the basics. I will do a lot of scripting, a lot of geek out stuff. I will show you the internal workings of Aspire and maybe show you a couple of features that you didn't see before, which are new in Aspire 13. So there should be something for everyone here. First, let's start with the basics. So Aspire, it used to be called .NET Aspire, and I need to correct myself whenever I say it incorrectly. So recently, with the release of Aspire 13, they decided it's no longer .NET, it's just Aspire. Well, that's mostly because nowadays they are also targeting Python apps and Java apps. You can do MAUI, well, that is .NET of course. So they are really broadening the ecosystem, and this is why they decided, well, let's go for Aspire instead. So Aspire, first and foremost, it is a tool that will help you in your development environment. So it's mostly about getting you up and running as a new team member. You clone the repo, you hit F5, and you are good to go. So that is the main purpose. So nowadays they have added all kinds of additional features, but still the core of the product is to help you as a developer get up and running in no time. And for this they have all these kinds of tools. I won't go over them all, but it is important to realize that Aspire is a C# project that you add to an existing solution, and what it does for you is launch all kinds of dependencies, and it will also launch your application itself. So it can immediately be up and running, and additionally it will add configuration so your apps know where to find each other and to know where they find the dependencies. Of course, I made a nice demo app to explain this not just in theory but in practice. So this is the AskVantage demo app, and if you are in the workshop yesterday it will look very familiar because we spent the whole day working with it yesterday. So this tool, what it does, it helps you study. So imagine you are a student or, well, you never stop learning, and you need to learn about a text. So this tool, it allows you to upload a picture of the text, and then it will send it to OCR, so it will extract text from the picture, and then send it back to the front end, at which point you can say, well, generate some questions and answers for me. And that will, of course, send it to a large language model, which is running somewhere on my laptop. And it will create questions and answers based on the text. So it is an application that actually does something, and it has some complexity to it. Finally, I chose to use Dapper for my state storage. So if you don't know Dapper, it's an abstraction tool that allows you to say stuff like save this state for me, and Dapper will find out itself where to put that state. And as a concrete state store implementation, you can pick and choose well, a lot of stores like blob storage, S3 buckets, containers. In this case, I chose a container called Redis, which is basically a key value store, which suffices for my needs today. Well, how does Aspire help me as a developer launch this application and all its dependencies? First and foremost, like I mentioned, it has a project that does this for me. So it runs my projects and it runs my dependencies. When my application is running, for example, my front end there, when it's running, it needs to know where the API lives. Otherwise, it cannot access it. Well, Aspire can configure my front end and inform it where my API is running. Then Aspire can also help me run Dapper. So Dapper was that tool that helped me save my state. Well, Dapper needs to be up and running. So it's an executable that needs to be running, and Aspire can do that for me. An abstraction is useless without a concrete implementation, and Dapper helps me in this case to spin up my Redis container so my abstraction can put the data somewhere. If I'm inside my API, already mentioned, it calls OCR and it calls an LLM. Of course, that API needs to know where to find those things. And Aspire helps me do so. Whenever I run locally, I chose to run the LLM straight on my development device, and Aspire makes sure that that LLM is up and running. And finally, maybe, just maybe, I want to test something like concurrency of my API and to see if it still behaves if I run 2 instances. And in the past, that would be a big deal because of port conflicts, and Aspire has a trick inside of it that avoids this port conflict. Oh, and of course the final step, which is an addition of late in Aspire, is that it can also help you deploy your application into other environments, like a test environment or maybe even a production environment. So that's quite a big list. So I put it in a checklist, and we will cross them off as we go through the presentation one by one. The first thing is to understand this app host a little bit better. So we need to demystify that. And then there's this thing we've heard about maybe, it's called the developer control plane. Well, let's dive into what that actually does. We'll talk about service discovery, so how the front end knows where to find the API. We'll talk about custom integrations. So maybe Aspire has a missing feature and you want to add it. You can even publish it to the community environment so the whole planet can use it, stuff like that. And the final step would be to deploy your Aspire application into different environments, which is not your local development laptop, but maybe some integration test environment. First item on the list, the app host. I copy-pasted this text literally from the documentation. It's a development time orchestration tool that simplifies the process of running and debugging your application locally. It sounds like the app host is quite an important part of Aspire. So let's see what it does with my demo application. The app host will be launched at some point, and then the first thing it will do is make sure that my state store container is present. I chose to run Redis, of course, so the app host makes sure that Redis is running. Once that is up and running, it can launch the API that wants to use that Redis state store later on, so it can configure it and launch it. If the API is up and running, we can run that Dapper process I was talking about. And of course, Dapper needs to know where the API is, so they can interact with each other. And also, it needs to know where Redis is. And the app host will be doing the work there. And finally, if the API is up and running, we can of course launch the front end, inform it about the location of the API, and then my whole application should be good to go. Well, let's see if that actually works in reality as well. That's a nice way to explain the application. So this is my VS Code environment, and I will show you this code later on while we wait for some answers. Aspire projects can just be launched from the development environment that you use. So if you look at the output here, the one main thing to notice is that there is something listening at 1888. And this is the Aspire dashboard, and we will be using it a couple of times today. But for now, I just want to see the front end, and that is this application here. So, like I mentioned, I can upload a picture of a book maybe, and then it will be sent to OCR. So this is a Shakespeare book. It's royalty free, so I can show it on the internet as well. And then I can generate questions. And because the LLM is running in a container on my local development device, it will take a while, and that gives me the opportunity to talk about the code that is in my app host. So, first and foremost, you start off with this thing called a builder, and it's not the web application builder, but the distributed application builder of Aspire. Then ignore this for a bit. So like I mentioned, the first step would be to add Redis, which runs as a container, but you don't see any complicated container stuff. No, it's just an extension method here that encapsulates all the complexity that is necessary to run Redis on my machine. So this is one of those community integrations I was talking about. The same thing applies to Dapper. We just say, okay, so here's the configuration file I need you to use for that Dapper additional process. I'm informing it about OpenAI endpoints, about OCR endpoints, and then finally it is time to launch my API project. So this project is just a project reference made from the app host project to the API project that makes it appear magically by some code generation in my app host, so I can run it as a project. Of course, I need to add all the dependencies myself. So I'm saying, for example, you depend on OpenAI, you depend on that Dapper sidecar I was talking about. All the dependencies are here. So I build this nice graph of applications and dependencies. And then I say run. Oh, I forgot my front-end project. Same deal, but then it's way less complicated because it just uses the image API and I can run it immediately. So this stuff, ignore it for now. That will come back later. But then the trick to get everything up and running is to say build, and the result needs to be run. I think I talked long enough now for the questions to appear. Yep. My LLM has been successful, so it's running locally. It has taken the text and generated some questions and answers. And well, you can, for example, see, well, Juliet is doing most of the talking in this piece. Okay, so we will be circling back to the application every once in a while, but for now, this is fine. So the app host is quite an important thing. It appears to be the orchestrator. It needs to do the application launching. It needs to configure stuff. It needs to launch the dependencies. So that's quite a big responsibility. Or is it? Well, it turns out that none of this is actually true. So the app host doesn't do anything that I just mentioned. The only thing that the app host does is take that code that you put there and generate acyclic directional graph from it, and that graph that specifies all the parts of your application, and that is handed off to a helper, and this helper is the developer control plane, in short the DCP, and the DCP is the thing that does all the heavy lifting here. So it is the orchestration engine and it executes all the application components, and it makes sure that your application and the dependencies are all up and running. So the app host is just a graph builder, and the DCP is where the real work is being done. All right, so let's quickly cross off the app host from the list and dive into that developer control plane. If you zoom in to the DCP, at the time of writing this talk, the DCP was fully undocumented, so I had to figure it out all by myself, and that's what we'll do in the next demo together. The DCP consists of 3 different processes. So there's, to make things complicated, there's a DCP executable, and a DCP control, and a DCP proc. So the DCP process, it is where the management API lives, that can be accessed by the app host. The DCP control has the muscle and capabilities to actually launch projects. And then the DCP proc is usually used as a monitoring process. And well, we'll dive into those in much more detail right now. So if you check out how this DCP comes to life, it all starts with a .NET process being launched. So it's either a .NET Run or an Aspire Run, depending on which CLI is your favorite. But at some point, a .NET process is executed saying, hey, I need to run the app host process. The app host process, of course, is that code I just showed you. So that's the app host executable, launched by .NET. And the first thing it does is launch the DCP executable. And it launches it in a detached state. So whenever the app host dies, it doesn't necessarily mean that the DCP dies, because it's no longer a child process. All right, now the API server is up and running, but there's more. There's this DCP control thing. And DCP control, again, is the thingy that will run the applications itself. So it takes the application graph that was passed all the way from the app host through the DCP to DCP control and starts up your application. In this graph, so this is my code because I wrote the app host. This is my code because that's my API in my front-end project. It can also be somebody else's code in the form of a container, for example. So that Redis container, you can also imagine that that one is living over there. So DCP control has launched my app. But now my app needs to be monitored because if it dies, we need to take action. And this is where the final process of the DCP stack comes into place, and that is the DCP proc. So its reason to exist is to gather telemetry from my app and to monitor both the parent DCP control and the child app. If you look at the monitoring, you can see a chain of processes, launching processes all the way up, and then the monitoring always works all the way down. So every child process will monitor its parent. So if one process goes away, everything goes away, and you end up with a clean system instead of floating orphaned processes everywhere. So that's kind of nice. Well, imagine you are not using the .NET CLI or Aspire CLI to run your project, but you do it from the IDE, like I just did. Then it's slightly different, so it's not .NET on the top of the list. The rest will be the same, so DCP control will be created by DCP, but it's not DCP control who will create the process instance. No, DCP control talks to the IDE over a secret port, passing in a confidential value. The IDE will say, "Hi, I know you, I trust you, I will launch that app for you." And while doing so, I will also attach a debugger for you. So this is how you can do Aspire debugging by simply pressing F5. And then, of course, you will get a DCP proc monitoring instance that will monitor your launched executable. And then everything works as before. So quite complicated, so I thought I would make a nice demo that shows this all. So let's go for the first demo, the first real demo. I'm using my trusty script runner for this, so I want to do live demos, executing real commands, but I don't want to make any typos, so I've put all the commands in my script file, and now I can execute them over here by using my clicker. You can also run an Aspire project as doing by Aspire run instead of .NET run or F5 in your IDE. Aspire CLI can also run projects. The ampersand on the end of the line there means that it's not running blocking, so I can use my terminal for other stuff, like maybe list all the processes. The PS command lists all the processes, and then I will filter based on the app host process name. And yes, there is now a .NET process that is executing my app host project. And you can imagine that the result of that is app host process. So if I look at the process tree of Aspire run, that caused .NET run, which caused my app host process to start existing. And you can see in the tree that one process launched the other. Okay, so I'll steal the process IDs of both, make sure that I have them, and then I can say, okay, let me see what processes are running that have that app host process ID somewhere in their description. And it turns out that there's a DCP process. It was launched by the app host, but it was launched in a detached mode, so its parent is one, but it's monitoring the app host. It can be notified if the app host dies, and then it will be the signal for the DCP to go away as well. So steal that process ID as well. And now I have two process IDs, and I can use the DCP process to find out which processes were started by the DCP. So we saw the .NET process, the app host process, the DCP process, and now we are investigating which processes were run by the DCP, which should be the control. So let's see if that's true. All right, so we have a DCP launching a DCP control. So in that sense, we're still on the right track here. And then what we expect is the DCP control to launch both our apps and monitoring instances of DCP proc, right? Steal its process ID and then say, what is the process tree of the DCP control look like? Well, that's a big list. Don't start reading it because we will be going over the details one by one. But you can already see it's quite a big list of processes. So let's clear them quickly and go over the .NET processes first. So as expected, the DCP has run my image API. It has run my front end. And the third one I got for free was the Aspire dashboard. I already showed you that quickly before. So whenever I run my Aspire project, I can also add a dashboard which indicates the status of my application. So it will indicate whether everything is running or no. So that's cool. Now let's have a look at the containers it's executed for me. I can't see them directly, but I can see how it was launched. So the DSP control, it monitors two types of events flowing from my container runtime. So I'm using Docker Desktop on my machine, and the DSP control is monitoring the network events from that thing, indicating that my container was launched and doing stuff with the network, like port forwards. And it monitors containers, so it can see whenever a container is being launched, or maybe if it gets killed or crashed. I'm not going to do this because it's just messy. Let's see the processes of DSP control that are DSP proc. So these are all the monitoring instances. I won't show you every one of them, but what you should notice is that every DSP proc will monitor the parent process. So again, the parent process would be the DSP control, and it monitors a child, which is different for every instance, saying, okay, this one is monitoring my project, this one is monitoring a container. And by doing this, I can have the telemetry from those moving parts all flow back to my Aspire dashboard. So every app that gets launched will have its own monitor that is responsible for getting the telemetry from that app and moving it to my dashboard. Now, the cool thing here is that in my process tree, if I kill any of the processes, so I just killed the .NET process, that will have a cascading effect. So if I now do a PS3 with the DSP process ID, it should be empty. And I talked for long enough, so it is actually empty. So my whole orchestration is now being cleaned up. So let me kill that and move back here. Okay, so that was kind of fun. The next topic would be the reverse proxy that is built into DCP control. I already mentioned that sometimes when you want to run multiple instances of the same app, in the old days you could get port conflicts. And this is a way to deal with that. So there's a DCP control built-in reverse proxy. So what happens is that whenever the DCP gets launched, it will run your applications. It will not stick to the launch profile that you passed in with your application. It will say, ignore that, take a random port and launch it at a random port. And then it will create the port that you passed in with your application and expose that on the proxy. And then it will forward traffic that arrives at the proxy and forward it to one of those random ports. So that can be quite complicated. So the way it looks in my application would be the front end. It wants to call the API. It thinks that it's listening at port 5000 or something. In reality, it's talking to that Aspire proxy over there, which is in DCP control. And the proxy will forward that call to the API itself. And of course, we can have the image API running at whatever port the DCP control pleases, because it launches the process, so it knows where to find it. And of course, you can do the same thing whenever talking to a downstream container. Right, so the reason why this exists is mostly so you can do multiple instances of your application. So I can now run multiple instances of my LLM container, for example, side by side without them having port conflicts. And the proxy is responsible to do load balancing across them. So that's kind of nice. And there are also secondary effects. For example, you can now do integration testing. You can have multiple tests run side by side, each spinning up their own tiny app host, and you can do parallelized integration tests on the machine itself without getting into port conflicts. All right, well, I have a really quick demo that shows this working as well. All right, so I go to the right directory and then do Aspire run. Once it's up and running, yes, I can steal some process IDs again, just like I did before, so I'm not going to explain it all over again. make a nice table. That's for me to see that every command worked. And I can do stuff like, so who is listening at port 5062? So if I'm correct, then it should not be the image API. Well, it turns out I am in fact correct. So you can see DCP control is listening at the port of my image API. I did forget to show you this, by the way. I'm sorry for that. So here is the launch settings file of my image API. And over here it says you need to run at 5062. So Aspire took this file, it took the port from it. It said image API start at a random port. I will take that port and put it in the proxy. And that's what you see happening here. So the proxy is listening at port 5062. And the nice thing is I can totally do a curl call and the proxy will forward my call to the real downstream API. What's even nicer is I can say, okay, so which port is my API listening at? And that appears to be either 56158 or 56157. This is because I have two endpoints, one HTTP and one HTTPS. So I'm now gonna guess which one it is and put that in my curl command. And if the demo guards are favorable, this will work. I guess the HTTP endpoint. So I now called my image API on the random port instead of through the proxy. So just to show you, there's no magic happening here. So you could see the proxy is there and it's nicely forwarded my traffic. There's another network thingy going on, and that is the DCP management API. So my app host, it needs to say, hey DCP, go and launch this application graph for me. So the graph I defined in my app host project. The app host created a nice graph from that. That graph needs to be sent to DCP, so DCP can launch the correct processes. Well, how does that work? So whenever the app host launches, the first thing it will do is allocate a random file on a temp directory. It's just a file name, and it will create a file which is empty, and then say, hey DCP, here is a random configuration file location for you. Okay, DCP will start up, it will pick a random port to start listening at, and then it will put the information to connect to it in that configuration file. So this is the way that the app host knows, okay, so the DCP lives here and here. So it can connect to DCP and start sending the application graph. Well, then, of course, we need the DCP control, which is the builder of the stuff, so it does the actual work of launching applications. So DCP will launch DCP control. It will say, here is the config file, and please connect to me whenever you get launched. So DCP control launches, it reads the configuration file, and it knows how to connect to DCP. And this way everything is now connected and we can start building the application. And again, don't just take my word for it, because I have a demo that proves this. All right, Aspire run again to run my orchestration. You will probably guess the next 5 or 6 steps, and that is to steal all the process IDs again. Make a nice table for me to see that everything worked. And now I can say, okay, give me the ports that DCP is listening at. Well, it turns out that DCP is listening at 57838. Okay, that's nice. So give me the connections of the app host then. And then if I'm correct, there should be a connection from app host to 57838. And yes, so 57838, that has been established to the DCP. So this indicates that app host is connected to DCP on network level. So the next thing would be to see what is the command line of the DCP. So remember that we were sending this configuration file to DCP, and the only way to do that, of course, is by providing a command line parameter. And that's what you see happening here. So this is the configuration file I was talking about. And notice the name for later. Now let me steal that file path from the command line and maybe investigate that file for a bit. So there's stuff in this file, and like I promised, it indicates where the DCP could be found. So 57838, that appears here, and this is how the app host knows how to connect to the DCP. And there's apparently a bunch more indicating a certificate for security purposes, and even an API token that you can send when doing calls to the DCP. So everything that we need to know on how to connect to the API server that is running in DCP. Well, the name already indicated it, so it's a kube-config file. So is it possible that we can use the Kubernetes API tooling to talk to the DCP management endpoint? Well, let's give it a try. So kube control, you usually use it to manage Kubernetes, and now I'm going to use it to manage my DCP. Well, it works. So instead of pods and deployments and all that stuff, Kubernetes stuff, it's now saying, okay, the formatting is horrible, apologies for that. It's saying stuff like executables and containers, this one. So apparently this connection now works and I can mess around with it. So let's see what the executable list looks like. Okay, so it's running the dashboard, API, front end, and the sidecar of the Dapper sidecar of my API. So exactly as I expected. So what if I want to get more details about the API process? Well, I can steal that from the output and get more details. Well, this is not incredibly interesting, but I can also look at the YAML output. And then all of a sudden, this looks very much like a Kubernetes resource. So it has a kind, which is executable. It has information about ports that it wants to use, for example. It has a command line. So this indicates that it wants to run my API project. No build, configuration debug, for example. And it indicates that, well, I don't pass in a port, so pick a random port. And this is again the way the proxies work, of course. So what would happen if I create my own executable file and put it on my disk in this folder here, and I want to run my own executables. Imagine that I have a custom executable and I want it to run at port 18880. It should sound familiar. And the executable in this question is the Aspire dashboard. And I want it to accept anonymous connections. So let's see if that works. It did. So I can now by name, so this is the name of my executable. I can by name fetch it and see, yes, I have launched my own application on the DCP. So that would also mean that because I said it needs to connect to port 188.0 here, I should also be able to do a curl call to that port. And yes, so this is in fact the Aspire dashboard running in a very deteriorated way on my DCP. So get rid of it. And we can do the same thing with a container. So let me show you that container file on my disk as well. So the kind is no longer executable. Now the kind is container. Okay, so which container do you want me to start? Well, in this case, I picked Nginx, which is a proxy or a web server, depending on how you use it. This is where you can find it. I want it to run at port 80. And then I want it to be exposed to my laptop at port 8080. So this is a port forward from my machine to the container. Just to prove you I'm not faking anything, I am looking at port 8080 now on my laptop. There's nothing running here. I run my container. And now I can check if that Nginx container is in fact running. So by name Nginx, I'm getting it. Well, it is created. And now, fingers crossed, yep, there is something listening at 8080. So I can check my containers running on my machine using Docker PS and filter for Nginx. Yes, there is one running, and it has been running for 24 seconds. So that looks kind of realistic. So I should also be able to open my browser and see, well, an Nginx container running here. So I'm kind of hacking around in the DCP here. Well, let's see what happens now if I kill my app host. So remember, if you kill one of the processes in the chain, it should clean up everything. Now let's see if that is true. If I'm too quickly, then it's not true, because the cleanup takes just a couple of seconds, so I'm talking over that. Let's see, okay, container is now gone, and if I refresh here, that should also be gone. So everything that I hacked into my DCP later on, it has been cleaned up nicely. If you look closely, then the DCP will remind you of the Kubernetes Management API. So it's not the same thing. It's not like the DCP is Kubernetes. They just share the same interface. And this also doesn't mean that you can run the DCP on production. Never do that. It has the same management API, but it is not intended to run in production ever. So don't run DCP in production, just on your laptop. That's fine. And the DCP control, that is a lot like Kubernetes worker node, or the kubelet. So it does all the heavy lifting. It looks at the application graph to see the desired application state and make sure that the desired state becomes the real state. So we can cross off the DCP, and from now on, those three processes in the DCP, they're just one. So I can say DCP, and you just think all three together, every functionality that it offers. So let's look at service discovery. I already mentioned my front end, it needs to run, and it needs to know where my API is. And the API, it needs to know where my LLM container is and where the custom vision API can be found. The way this works is by an existing ASP.NET Core feature called service discovery. So this is not Aspire functionality. No, this is ASP.NET Core functionality. And that's a good thing, because this will run in production. So this is part of your API or your front-end code, and it will be executed in production. So it needs to be part of the framework. So the way it works, you call an extension method, and that has an effect of HTTP clients to get a customized handler within. And the handler, it intercepts a request, and whenever it can deal with that request, it will execute it for you. And the nice thing is, using Aspire configuration settings that you can feed into this, you can say, okay, my DCP control, it launched my image API, so it knows where to find it. So it can provide configuration to my image API process or my front-end process, indicating where it can be found. A little bit complicated maybe, but if you see this, then maybe it makes more sense. So you have a template here saying, okay, this is the way services need to be annotated. So you have a service discovery section first, named services. Then you have the name of your resource, in my case an image API, or it could be something else. Then a named endpoint, so it could be HTTP or HTTPS or whatever you prefer. You can also put your own name here. And then the 0 means that you can have one or more entries. So it's you could have a localhost 5062 and example.com 443, so whatever you please. So you can have multiple entries. A different way to do exactly the same thing is just by using a configuration file. So again, you have a services section, you have the name of the thing that you want to be resolvable, and you have a named endpoint and an address. And the nice thing of this approach is that you can put a port number in as well. So I can now say in my code I want to go to image API, and it will resolve to everything including the port number. So it really simplifies service discovery within your application. So the way it works, the DCP runs everything, so it knows where everything lives. So it can add configuration values to the stuff that it launches, indicating where they can be found. If you apply this to the demo application, so the the front end, it needs to know where the API lives, and the API needs to know where the LLM container lives. This is a nice and quick demo about service location. Okay. Yeah, looking good. So run my application. And don't worry, no more ports, no more process IDs. I'm just going to show you the dashboard, because this is clean enough for the demo. So imagine that you are launching the front end. The front end needs to know where the API lives. So we can inspect the environment variables that Aspire passed into the front end. Scroll all the way down. And there you can already see, if I can, like I promised, there's a services section, the name of the downstream resource I want to use, 2 different types of endpoints, one HTTP, one HTTPS. And then if I slide back, I can click on view. And as promised, the HTTP endpoint is 5062. So, and remember, this points to the proxy, but you don't need to know that as a front end. So that's kind of nice. The API, it needed to know where the LLM container lives. So it also got services, but then a different name, question generator, and it only has one endpoint, so it's only HTTP, and that is pointing to localhost 11434. The next step would be to have a look at the code and see how it is processed. So in my front end is a single page web app, so it runs in a browser. The only thing it needs to worry about is doing API calls to wherever it came from. So it is hosted at a certain address. So the HTML files were served from a certain endpoint, which is localhost. And whenever it wants to do an API call, it will just send it to localhost. But of course, my API is not running on that same port, because that is the front end. So we need to deal with that a little bit. And the way to deal with that is to add service defaults, which enables, among many other things, service location or service discovery. And I can add a forwarder that uses the information from service discovery and forward my calls downstream. So whenever my front end single page app calls wherever it came from, /API, I can intercept that and send it downstream. And the way that works is by these forwarding calls. So whenever I want to call my image API, it's being sent to, that pop-up is annoying, to API/image downstream. And where is that thing? Well, it's image API. So I'm not providing any further details here, because service discovery resolves this into the correct API URL and correct port. So only thing I need to do this is put this string here and then say F5, and it will always run. So because it's configuration based, Aspire will provide configuration on my local development environment. But if I go into production, I can add a configuration section like this saying, okay, so we're now in production and now I need to use a real endpoint instead. 0 code changes. So it's really nice and clean. All right, so the next step would be to start looking at these things called custom integrations. The way this works is by simply hooking into the existing technology that Aspire offers you, and that is based upon this fact. So everything in Aspire is a resource. So projects are a resource, connection strings are a resource, dependencies between projects can be made. And by this means, you can build an application graph, of course, but if everything is a resource, that means that you can also put behavior in it, so behavior in the form of code. And Aspire does this by offering you all these kinds of different interfaces. So maybe one that declares I have an HTTP endpoint or I am a container resource. And by adding these interfaces, you can tweak the behavior of a resource. The main reason, of course, for this is that Aspire wants to build this graph from it. So it needs to know which parts make up your application and which depends on which other thing. It is really nice to have this graph in memory and use that to create maybe information for the DCP to launch these projects. So these are probably Kubernetes manifests being sent there. On the other hand, you may be able to use that graph for different purposes as well. And that will be the main idea behind publishers that we will talk about later. But for now, let's stick with integrations first. So again, when I made this talk, there was no such thing as an Ollama extension. Right now there is. So in your mind, pretend that it doesn't exist and we want to build it today. The first thing you need to do is to say, okay, so I need to add this extension that will run my LLM container to my orchestration. And that means that I need an extension method to put in my app host. So that builder thingy we talked about before, it needs an extension method to add my container that runs Ollama. So the way you do this, if you follow the book, you will add a new project to your solution, or maybe a new project altogether. And then you would name it aspire.hosting and then whatever you name it. For example, Ollama or XYZ, whatever you please. And keep in mind that the host part is never run in production. This is part of the app host, and we will never run the app host in production. So this is a way to spin up Ollama on my machine, but not to spin it up in production. I'm going to say that a couple more times, so bear with me. So sometimes it makes sense for your application code to integrate with that host integration. So maybe if I add a few methods, it would make it easier to use that Ollama container, both in production, but also when running on my local dev machine. So this is why you also have these things called client integrations. And their naming is a little bit simpler, so that would just be aspire.ollama, for example. And sometimes you have these things called community extensions, and so this is the Aspire Community Toolkit. So if you ever think, hey, I'm going to build an Aspire extension, check this one first, because you don't want to end up like me building an extension that is already here. There are quite a few to choose from. So nowadays it's probably nicer though to go to aspire.dev. So this is the new Aspire website. If you want to do some reading, this is the place to start. Let's see what I built. The first thing I did was to create aspire.hosting.ollama extension. And like I mentioned, that is an extension for my app host. So no production code, just to simplify my life as a developer. The other thing I did, I wanted to run Dapper sidecars. I picked a community host extension for that. So that is the community toolkit.aspire.hosting.dapper. And that makes sure that a sidecar gets launched whenever I run my app host project. And then final thing, optional step to do is to say, okay, I also have a little bit of client knowledge that I want to share with the planet. So I'm also adding a client integration. So you don't need them usually, but sometimes it makes a lot of sense to have a client integration as well. And of course, I'm not just talking, I already did the work as well. I have put it here. So it all starts with the distributed application builder. So this is the extension method that you can put on your distributed application builder. Maybe I should start there, just for fun. So in my app host, I want to say add Ollama. And then I want to define a bunch of properties, but I don't want to explain like all the way how Ollama should be run. I put all the complexity inside this package, so I can just say, well, run it with this name and use this model and use this port. I don't want to have NVIDIA GPU acceleration because I have a MacBook, so it doesn't make a lot of sense. And then go nuts. And that brings us to this method, and this is an extension method that launches my custom integration. And the first thing it does is hook into the application lifecycle management, which we'll talk about later. It says, hey, so create a new resource, configure it with the provided default tag, or maybe a tag that the user has provided in the call. Make sure that it remembers the models on disks by adding a Docker volume. And if I did enable verbose logging, pass in a few environment variables. And if I did enable GPU, then you also need to configure the container a little bit. So all the complexity has been put away in my extension method. And the only thing I need to do in my host builder is say add Ollama. Okay, then the resource itself is nice and clean. So I'm just using the Aspire container resource, and that does all the heavy lifting for me. So it knows how to talk to my container orchestrator, it knows how to download images, it knows how to start them, and how to do port forwards and everything. So The code of this is kind of clean. I just say, okay, so I'm exposing a single HTTP endpoint, and whenever somebody gets it, they should use this name. And just for fun, I added these model names. This is not the whole list, of course, but this also helps the end user pick and choose their favorite models a little bit easier. Whenever I run my Llama container, the pulling of an image, it can take quite a bit of time. So I don't want my end user to panic and think, you know, that thing is not working, we need to get rid of it. Now I want them to have information that it's actually doing stuff. And maybe you have an internet connection that is not very fast. So whenever my model is being downloaded, I want to notify the end user that that is happening. And of course, the way to do that is to hook into the dashboard. And this is the way you would do that. So you create an event subscriber. You implement the distributed application eventing subscriber. Quite a mouthful, but the only thing you need to do is say subscribe async. And then you can say, okay, which types of events do you want to subscribe to? There's a whole list of events, so you can do it before the resource is created or after it's created, maybe before it is stopped. So all these lifecycle events, they are here for you to hook into. I should say that not all the events work equally well, so it's a little bit buggy because this is a very new feature. This one works, so maybe just use this one then. So after the resource has been created, we will download the model in the background. Of course, we can only do that once, so I will first check if a model exists using something called an Llama client. So I'm now doing an API call to my container to say, hey, do you have this model? And if no, then go and download it. And during the download, which is here, it continuously says, okay, so I will publish updates about what I'm doing. So I'm now saying to the end user on the dashboard, I'm downloading a model. And then during the download, you get this await for each. So it's a thingy that keeps on cycling until the model has been downloaded. So I can do nice things like update percentages. So you can really interactively see on the dashboard the model is being downloaded, and even if it takes 4 days, you will still, have the confidence that at some point your extension will be up and running. This was recently all changed from a totally different approach. So if you see the old code, keep in mind you need to replace it with this, because in the next version, the old style of lifecycle events, it will be gone. Okay, so getting close to the end here. How about deploying to other environments? Like I said, and this is the final one, I promise, don't run the app host in production. But what can you do with the app host while you are thinking about going into production? Well, you can use that graph functionality and maybe use that as input for transformation processes. So imagine you have this op graph and you say, well, my end situation is Kubernetes, for example, or Docker Compose. So 2 ways of running your entire application as containers on Container Orchestrator. Well, you can use that graph to determine, okay, so I need to build a container for my image API, I need to fetch the container for Redis, and I can definitely use that app graph as information to make these decisions on. And this is when we get into the country of publishing and deployment. It turns out that there are these publishers. Again, this is mostly community work. So Aspire has said, here's the graph, feel free to start working with it. And then people have decided to work with it and say, okay, well, using that graph, I can make deployment for Azure Container Apps. So just hit F5 on your publisher, sort of, and infrastructure will be generated in Azure and your application will be pushed there immediately. I'm not a big fan, but you can definitely do this. Same deal for app services in Azure. So it will provision infrastructure and then put your application there. For Kubernetes, it's slightly different because Kubernetes, of course, it has these manifests. So it has already got a way to provision applications. So the publisher for Kubernetes will just generate that manifest for you. And the same thing for Docker, it will generate the Docker compose file, which you can then apply to your container orchestrator. Okay, so the trick of these publishers is kind of straightforward. So it's C# again. The input would be your acyclic graph, and the result would be a file on disk or infrastructure in Azure, or maybe something that hasn't been invented before. So you can do it yourself as well. So you can write your own publishers if needed. And that brings us to the next step, which are Aspire pipelines. So imagine you want to deploy to Azure Container Apps, and you can use these things called Aspire pipelines for that. So you will add resources to your graph, saying, okay, whenever you encounter a project, then it needs to be compiled. An image, a container image needs to be generated. That generated image needs to be pushed somewhere to Docker Hub or a private registry, and then it needs to be deployed to infrastructure here and there. So it's very similar to GitHub Actions or Azure DevOps pipelines. So you can build these things nowadays in your app host. And by doing so, you can do local development, and then if you're ready, say, okay, now deploy the test environment or deploy the production environment. Again, I'm not 100% convinced that this is a really good way to go, but it is a feature nowadays. So the way you would do that is by running Aspire deploy to run the entire pipeline, or since 5 days, you can also do Aspire do to run a single step of your pipeline, and that is convenient if you want to test the single step. One example I stole from the Aspire website of a pipeline, and again, this is so new that I don't have very delicate working code, so bear with me here. So if I want to deploy my service, the first step in the pipeline could be to compile it. In the meanwhile, create some resources in a cloud somewhere, push the container image into that registry. While you are doing that, make sure to provision a database somewhere. Make sure we can access it with a managed identity. And then if everything is up and running, deploy the whole application there. So you could build this today in these pipelines. It's a bit of work, but you can do it nowadays. So go to the right directory, and instead of doing Aspire run, I'm now doing Aspire publish. It's already scrolled out of view, so let me see if I can find it. Aspire publish, and then I provided it with an output path. Well, this is not magic happening here, so publish by itself doesn't do very much. But what you should notice is that there is a custom deploy step. That's kind of interesting. That's not part of the out-of-the-box experience. And there's a file written on this path. So let's see what happened there. Okay, that brings us all the way down here. And the reason I can do a publish that has a meaningful result is because I added a resource to my graph that understands what publishing means. So this is a new resource in my graph saying, okay, I know how to publish applications as Docker compose files. And because it's part of a graph, it can traverse the graph and find out everything it needs to know. So the complexity is in this extension method here. And what it did, if I can find it, yep, it created this file for me. And if you know Docker Compose at all, so this is everything you need to run, well, the question generator, to run Redis, to run the dashboard, the image API. So everything we need to run this application, not in Aspire, but on some kind of a Docker environment somewhere. So kind of nice. All right, but how would you deploy it then? The deployment would be to do a publish with resources that know how to publish. So you would add stuff to your pipeline that say, okay, so at this point in time, I need to deploy infrastructure somewhere, for example. Well, I didn't do that. I just added the Aspire do custom deploy step to debug my single customization. It didn't deploy everything, so I don't have a new Docker Compose file, but it did execute my custom step. Let's check out the code of that custom step. And it's, well, It's very simple, but it's only intended to share the point with you. You can hook up your own code, so within this action that needs to be executed, you can type any code that you need, and it's async, so you need to return a task or await some stuff. So you can in fact do resource deployments on Azure or AWS or whatever is your favorite deployment environment. And then by adding many of these steps, all with their own name and with their own context. So this is a publishing step. You can also have build steps or look into it. Really, this was released just a couple of days ago, so it's really hot off the presses. But you can imagine that by chunking up or chaining up many of these calls, you can deploy your application to, well, wherever you want, because it's all written in C#. So wrapping up, if you really want to understand Dapper, realize that the app host in the books, it's doing all kinds of stuff. In reality, it's not doing very much. All the heavy lifting is being done by DCP. You can play around with the DCP because it has a compatible, Kubernetes compatible API. If Aspire doesn't do what you want, you can easily extend it. So most of the classes are just public and inheritable, so you can override behavior that you don't like or extend behavior that you do like. Well, if you want, you can use Aspire pipelines to deploy to any environment which is not necessarily your development laptop. And with that, we have come to the end. If you want to get in touch, feel free to connect on LinkedIn or maybe visit my GitHub page. If you want to look for the sources, that is Ask Vantage, the repo. There's a script runner tool. It's also free to download. And well, many other goodies if you want them. And thank you all for coming. And if you have any questions, feel free to come up to me and talk.